Okay, so Unit 11F handout, which was a homework one, and this will be the solutions to all of them. So make a mark of anything that still doesn't make sense after you watch this so that if you have questions, you can still ask them in class. So we want to find the area of the rhombus. So all the sides are 14. Um, and we got an angle that measures 67. And remember, a rhombus, one of the super important features is if I chop it with the diagonals, I get 4 congruent right triangles. The 67, since I cut an isosceles triangle in half there, that gets cut in half. So each one of these is 33.5 degrees. Let me zoom in a little bit on this. There we go. That's a little bit better. Okay. So I don't know. I'll call this part y and this part x right there. So it's xx, yy. So let's do, I don't know, let's do sine to get y. So sine of 33.5 is the opposite side over the hypotenuse. So then if I multiply over the 14 and plug that into a calculator in degree mode, I'm going to get y is 7.727118. And if I do the same sort of thing but use cosine, then I can solve for x. So I'll multiply over the 14. And in that case, x ends up being about 11.674402. And then I want to get the area of one of these triangles. So the area of one triangle is going to be half the base times the height, which is x times y. So that's going to be half 11.6744 blah, 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 times 7.727 blah, blah, blah. And if you cut and paste those from your calculator, you end up with one triangle being 45.1047-ish. And then the rhombus is really 4 of those. So the area of the rhombus is 4 times the area of the triangle. So if I multiply this guy by 4, you end up with 180.419. All right. And then there were no units for this one. This would be units squared, whatever the units were, if I gave them to you. Okay, so that's number 1. Number 2. Suppose a certain circle has the same exact area as a certain square. All right. Radius of the circle is 10 inches. And I know that the areas are going to be the same, so let's figure out what the area is. The area of the circle is pi r squared, so pi 10 squared, 100 pi, which is 314.159, what is it, 1, 2, or 2, something or other, 2654. All right. Well, I know that's the same as the area of the square because they have the same exact area. So the area of the square is 314.159, blah, blah, blah. And I know that a square, all the sides are the same. And I know that it's a rectangle, so the area is x times x, length times width, which is x squared. So then to get the side of the square, I'm just going to take the square root of that thing. And if you plug that into a calculator, you get x is 17.7245. So if we round it to 3 places, it'll be 17.725. And then let's see. The radius was in inches over here. So then these lengths are going to be in inches too. So that's in inches. All right. Let's take a look at 3. Okay, so it doesn't say it's a parallelogram, but it is because these two sides are the same and those two sides are the same. And we learned if you have a quadrilateral that has this property, then it's got to be a parallelogram. So we also know that the area of a parallelogram is base times height. But we don't know either of them. So we know the base is x. So it's x times whatever the height is. And I know that the area is 600. So actually, let me write this down here. 600 is going to be the base, which is x, times the height, which we don't know. So I can't do anything with that yet, but we can solve for the height. So let me draw that in. So if I sketch the height right here, I'll call that h. Well, I can use trig. I've got the 65, h is the opposite side, 20 is the hypotenuse. So I'm going to use sine. So sine of 65 is the opposite side h over the hypotenuse 20. And I can multiply the 20 over. And h ends up being 18.126156. So I can plug this in right there. So now I've got 600 equals x times 18.126156. And then I can divide both sides by the 18. These guys cancel, and you're left with x is 600 divided by that 18, which is 33.101. Oh, and in this case, since the area was inches squared, the length for x will just be inches. Okay, so that's 3. 4, I think, is probably the trickiest question, the way most people are going to do it. And then I'll show you a shortcut for this particular probability problem. So we want to show that a point that I randomly pick from inside the hexagon will end up in that green rectangle in the middle. So probability of landing in the shaded region, that's going to be the shaded area divided by the total area. Okay, so let's figure out the shaded area. So I'm going to do this. I'm going to draw that hexagon by itself first. Now, there are a few different ways to get the area of the hexagon. What some students are going to do is the n minus 2 times 180, 6 minus 2 times 180 gives you the total of all of the hexagonal angles, and then you can divide that by 6 to get one of them. And if you do that, you get 120, so all these guys are 120. But you could also do this a slightly different way. You could chop it up from the center of the thing, since it's a regular polygon, and say one of these angles is 360 over 6, because there's 6 of them, and they're all the same. So each one of these is going to be 60 degrees. Okay. And then when I chop it right down the middle, like that, then I'm going to get 30 and 30, and these are 60 and 60. And the whole base here is 10. So this is 10. Which means if I draw this triangle by itself, this is 5 and 5. It's 60, 60, 60, so if this side is 10, then these sides are 10. You could do Pythag to get the height if you wanted, but you could also use the 30, 60, 90 theorem. So if you did that, that goes with 1, root 3, and 2 for 60 and 30. So I know that, let's see, 5 goes with 1, the same way that, I'll call that x, the same way that x goes with root 3. So then if I cross multiply, 5 root 3 is x. So now I know that this height is 5 root 3. So that's, whoops, this length right here, 5 root 3. Well, if I did the same exact thing up here, this would also be 5 root 3. So if the question is, well, what's the height of the rectangle? That's this length right here. Well, that's 5 root 3 plus 5 root 3, which is 10 root 3. So the area of the rectangle, the shaded area, area of the shaded is the same thing as area of the rectangle, which is base times height, 10 times 10 root 3, which is 100 root 3. And I don't know, somewhere I've got that. Let me see what that is. Hold on. I think it's like 170 something. 100 root 3, yeah, it's 173.205. I'm actually going to leave it like this. But there's that area. Okay. Now, if I wanted, so that's the shaded part. That's going to go on top, 100 root 3. The total area is the area of everything. So that's the area of one of these triangles times 6. So one of the triangles, area of one triangle, is going to be 1/2 the base, 10, times the height, 5 root 3. So that's 5 times 5 root 3 is 25 root 3. So the area of the hexagon is 6 of them. So that's going to be 6 times 25 root 3, which is 150 root 3. So that goes here. That's the total area. Area of the total. So that goes underneath here, 150 root 3. And then notice the root 3's are going to cancel. I'm left with 100 over 150, which is 2/3, or 0.6 repeating. Or if you turn that into a percentage, that'd be 66.6 repeating percent. So that's the probability that it'll be in the shaded region. Now, that's 2/3, which is a pretty simple answer. So oftentimes when there's a simple answer, there's a simple way of showing it. So let me show you this other way of doing it. Okay, so I'm going to cut this thing up, the hexagon up, into a few different pieces here. Oops. Just like this. And then I'm going to slice each of these triangles in half, like this. Just like that. Okay. Now, if I gave you a diagram that looks like this, and I said, oh, that part's shaded, what's the probability of getting in the shaded region if you pick a point in the square? Most people can say pretty quickly it's 1 out of 4, 25%. If I did this, well, then most people could say, well, it's 2 out of 4, or 50%. So in this one, all these triangles that I drew, all these right triangles like that, they're all congruent to each other. So how many shaded ones do I have? Well, I got 1, 2, 3, 4, 5, 6, 7, 8 shaded. 8 shaded. How many total do I have? Well, 9, 10, 11, 12. So I got 8 shaded over 12 total. And that's 2 out of 3, or 66.6%. Okay, so this, if you can see a nice trick like that for doing the problem, then go ahead and do it that way. Otherwise, you're going to have to go through the area routine. All right, number 5. Okay, so we've got radius 10, center point 4,3, the line y equals 9. Find the measurement of minor arc AB, which means the degrees. So let's go ahead and draw in some radii. We know this is 10 and 10. And then I know that I can go straight up to make a slope triangle. And if I do that, let's see, it goes from 3 to 9, so that's going to be 6 units up. And I need the measurement of minor arc AB, which is really going to be however big this central angle is. So if I call each side theta, then I can double theta to get my angle, to get my arc measurement. So let's solve for theta. Let's see, 6 is adjacent, 10 is hypotenuse. So if I do cos theta equals 6 over 10, then theta is going to be cos inverse, which ends up being 53.130102. And then measurement of arc AB, that minor arc is really 2 thetas. So if I multiply this guy by 2, I get 106.260 ... 2602 degrees. So if we round to 3 places, 260. Okay, the second part says, how long is this arc? So the mistake students make is they say, well, it's 106.260, but that's how many degrees it is. The other mistake students make is they solve for this length, which happens to be 8. Whoops. This length is 8, and then they double it and get 16. But I didn't ask for chord AB, I asked for arc AB. So the arc, that L there, is a fraction of the circumference. What fraction of the circumference is it? Well, it takes up 106 degrees out of 360. So the arc length is going to be a fraction of the circumference. 2 pi r, 2 pi 10. Right, so this is a percentage of the circle's circumference to get the arc length. And if you plug that into a calculator, you get 18.5459, which turns into 18.546. Okay, I hope that helps a little bit, and I hope to see you guys soon. Take care.